Let's try some factoring problems with multiple variables. 5x squared plus 13xy minus 6y squared. So we first check to see if its distributive property can work, and it cannot because all three terms do not contain the same variable. The last term doesn't have an x, the first term does not have a y, and there is no number other than 1 that goes into 5, 13, and negative y squared. Negative 6, I mean. So let's go straight to a binomial pair. We can split up 5x squared as 5x and x, and then we got to find factors of negative 6y squared. Since it contains a y squared, each of the factors we have is going to have a y in it, because y times negative 6 would be negative 6y squared, or we could have negative y times positive 6y, and that's negative 6y squared. Could also use 3y and negative 2y. We could do negative 3y and positive 2y. We've got to find which set of factors multiplies to be negative 6y squared, but it will help us add up to 13xy. So we can use positive 3y over here and negative 2y over here. That gives me negative 2xy as my inside terms, positive 15xy as my outside terms, and that does add up to 13xy. So I do have it correctly factored. Z squared plus 2yz minus 3y squared. We cannot do a distributive property on that one, so let's just do a binomial pair. The only way to split up z squared is z and z. Factors of negative 3y squared, that will help us add up to 2yz. One such factor would be negative 3y and positive y, or we could use negative y and positive 3y. So I'm going to use negative 3y and positive y to see what happens. The inside terms is negative 3yz. The outside terms is just yz, and that adds up to negative 2yz, but we need a positive 2yz. So the quick fix on that is that I do have the right numbers, but I have the wrong sign. So let's change the negative 3y to a positive 3y, and then change the negative y to the positive y to a negative y. So that gives me inside terms of positive 3yz and outside terms of negative yz, which will add up to positive 2yz. So this is the correct factorization on that one that I just accidentally tried to erase, but hopefully you can still see it. 3z squared plus 2yz minus y squared. Can we do a distributive property? We cannot. So let's try a binomial pair. 3z squared, we can only split that up as 3z and z. And the only way to split up negative y squared would be a positive y and a negative y. So if I do negative y over here and positive y over here, do have to check it. I get negative yz for my insides. My outsides are 3yz, and that does add up to 2yz. So I got that right first try. The last one is negative 6x squared minus 23x minus 20. So back to just a single variable on this one. The ways to split up negative 6x squared, and there's going to be several, because there's negative 6x and x, but there's also positive 6x and negative x. There's 3x and negative 2x, and there's also negative 3x and positive 2x. So there are 4 different ways to split up negative 6x squared. However, since we have a negative leading coefficient, since the first term is negative, one of the ways to factor quickly is to get a positive lead coefficient. And the way we can get a positive lead coefficient is just simply factor out a negative 1. When you factor out a negative 1, you'll divide all the terms by negative 1 to see what's left inside parentheses. So that would give me a positive 6x squared, a positive 23x, and a positive 20. So now the only ways to split up 6x squared is just 3x and 2x, positive 3x, positive 2x, and we could do positive 6x and positive x. So there's only 2 ways to split up that 6x squared, whereas if I left it negative, there would be 4 ways. So you wouldn't be wrong to leave it negative. However, notice you're making a lot less work for yourself. Also, moving forward, you will appreciate a positive lead coefficient in the rest of the things that we do. So if you do have a negative lead coefficient, start by factoring out a negative number so you can get a positive lead coefficient. So we still need to check to see what's inside parentheses. So we need to do a binomial pair. Let's split up 6x squared as 3x and 2x. And we need factors of negative 20 that will add, factors of now positive 20 that adds up to positive 23. So such factors would be 1 and 20, 2 and 10, 4 and 5. They both need to be positive to add up to a positive 23 and multiply to be a positive number. So let's try 4 and 5. 4 times 2x is 8x. 3x times 5 is 15x, and that does add up to 23x. So we do have it correctly factored. Remember, the negative 1 you factored out is part of the factorization, and to make sure you include that in your answer.